Hey everyone, notes 5.7 are verifying properties of quadrilaterals, and just a reminder, a quadrilateral is just a polygon with 4 sides, which is listed right here for you. And if you notice, there's lots of different properties that we have here for different types of quadrilaterals that exist, and there are also some properties here that are important as well. I'm not going to go through and read them to you because you know how to read, but make sure that you look back at this if you ever need to refer back to it. All right, so question number 1 asks us to classify quadrilateral ABCD, which is defined by the following coordinates. So let's go ahead and graph them all out. So A is at -5, 3. B is at -4, -2. C is at 7, -1. And D is at 6, 4. Okay, and I want to classify the type of quadrilateral that we have here. And if you take a look here, we've got a lot of different definitions that we have for these quadrilaterals. So a lot of it is based on like side lengths right here. So here we've got side lengths are equal. Here we've got side lengths are equal. Parallel sides will have us looking at slopes. A right trapezoid, which means that we have a right angle, will also have us looking at slopes. So we're looking at distances and slopes pretty much. So let's go ahead and just label these coordinates first. So let's first start by looking at side lengths. So the first thing I'm going to do is find out what AB is right here. So just a reminder that the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And for this, you're probably going to want to write small. So let's find AB. Okay, so to find AB, I'm going to do the square root of x2, which is -4, minus x1, which is -5. So I'm going to do -4 minus -5, which is +5. And then I'm going to do y2 minus y1, which is -2 minus 3 squared. So then I can go ahead and evaluate these. So -4 plus 5 is 1. And -2 minus 3 is -5. So I end up getting the square root of 1 plus 25, which is the square root of 26. So here we can say that AB is equal to the square root of 26. All right, next I want to find the next segment in my figure here, in my quadrilateral here. So the next thing I want to find out is segment BC. So let's go ahead and do that. So for BC, I'm going to do x2 minus x1, which is 7 minus -4, but the minus and negative becomes a positive, plus y2 minus y1. So I've got -1 plus 2 squared. So I end up getting 11 squared plus 1 squared, which is, the square root of 11 squared plus 1 squared, which is 121 plus 1, which is the square root of 122. So here we can say that BC is equal to the square root of 122. And if you notice right here, it's clear that this is definitely not going to be a square because the side lengths are not the same. I mean, you could tell just from the picture right here, but we have shown mathematically that it's also just not going to be a square. So now the next one I want to find is CD. So let's go ahead and find out what CD is going to be. So for CD, I'm going to do the exact same thing that we've done for all of these. x2 minus x1 squared plus y2 minus y1 squared. So I get the square root of -1 squared plus 5 squared. So here I end up getting the square root of 1 plus 5 is 25. 5 squared is 25, so I end up getting the square root of 26. So here we can see that CD is equal to the square root of 26. Okay? And then lastly, I want to find out the length of DA. So let's go ahead and calculate that length right here. So to do DA, I'm going to do x2 minus x1. So I'm going to do 6 minus -5. Again, it doesn't matter what order you do it in, as long as you are consistent. So since I put the 6 in first, for the x's, I'm going to put in the 4 in first for the y's. So 4 minus 3 is what I'm going to put in for my y values here. And I get 4 minus 3 squared. So 6 plus 5 is 11. 4 minus 3 is 1. So here I end up getting 121 plus 1, which is square root of 121 plus 1, which is the square root of 122. So here we can say that DA is going to be equal to the square root of 122. All right, so if you notice right here, we can say that the opposite sides are in fact equal to each other. right? We got the square root of 122 on opposite sides, and then we've got the square root of 26 on opposite sides. Okay, now I need to take a look at my slopes. So the next thing I'm going to do is I'm going to find the slope of each one of these segments here. So I'm going to find the slope of AB, and I'm going to do y2 minus y1, so negative 2 minus 3, over x2 minus x1, so over negative 4 plus 5. So I get negative 5 over 1, which is negative 5. Okay, then I'm going to find the slope of BC, and I'm going to do the same exact thing. I'm going to do negative 1 minus negative 2, which is negative 1 plus 2, over 7 minus negative 4, which is 7 plus 4. So here I get 1 over 11. Okay? Now let's find the slope of CD, and the slope of CD is going to be 4 minus negative 1, which is 4 plus 1, over 6 minus 7, which is still 6 minus 7. So I get 5 over negative 1, which is negative 5. Interesting, these two have the same slope. AB and CD, these line segments that are across from each other right here, both have the same slope. Let's see about the slope of AD. So to do the slope of AD, I'm going to use 4 minus 3 over 6 minus negative 5, which is 6 plus 5, and I get 1 over 11. So these two also have the same slopes, which means we can say here that since AB and CD both have the same slopes, they are parallel to each other. And then we can also, and that symbol that I just drew on here means parallel. We can also say that AD is parallel to BC because they have the same slopes. So we can write, we know for a fact that this is going to be a parallelogram. How do we know this is a parallelogram? Because opposite sides are congruent and parallel. So here we can say, in our concluding sentence or our concluding statement here, we can say that AB is equal to CD, which is equal to the square root of 26, and BC is equal to AD is equal to the square root of 122. So opposite sides are equal. Okay? We can also say that the slope of AB is equal to the slope of CD, which is equal to negative 5, and the slope of BC is equal to the slope of AD, which is 1 over 11, making AB parallel to CD. I'll zoom in on this a little bit so you can see this. And BC is parallel to AD. Therefore, ABCD is a parallelogram. And that is my concluding statement. That's my classification. It is a parallelogram. It's not a square because we don't have congruent sides. It's not a rectangle because we don't have right angles. It's not a rhombus because we don't have congruent sides. So all we can say here is that it is a parallelogram, which is quite a bit, to be honest. Okay? All right, and that's it for number 1. All right, in number 2, it says, given rectangle A, B, C, D, prove that the diagonals bisect each other. So there's 2 different ways we can do this. Before I do anything, I'm going to go ahead and graph out my points. So A is at negative 5, negative 1, B is at negative 5, 4, C is at 7, 4, and D is at 7, negative 1. And we can say we want to prove that the diagonals are going to bisect each other. So I'm going to draw my diagonals in, and I want to show that they're going to bisect each other. Now, there are 2 different ways that I can do this. So let's look at 2 different methods. The first method is to just find the midpoint, okay? So we want to show, our method 1 is going to be to show that AC and BD have the same midpoint. Because if they have the same midpoint, that means that they have to bisect each other, because bisect means they're going to cut each other in half. So we know that AM has to be equal to MC, and we know that BM has to be equal to MD if they truly have the same midpoint. So the first thing I'm going to do is find the midpoint of segment BD. So to find the midpoint of BD, I'm just going to do the midpoint formula. So just a reminder that the midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. Okay, so here I'm going to do x1 plus, I'm going to do x1 plus x2, which is negative 5 plus 7 over 2. And then I'm going to do y1 plus y2, which is 4 plus negative 1 over 2. So when I do this right here, I end up getting 2 over 2 and then 3 over 2, which becomes 1, 3 over 2. So this is the midpoint of BD. Okay, then I'm going to find the midpoint of AC. So to find the midpoint of AC, I'm going to do the exact same thing. I'm going to I'm going to add negative 5 and 7 together as well. Divide that by 2. And then I'm also going to, for my y values, add negative 1 and 4 together and then divide that by 2. So I end up getting 2 over 2, 3 over 2, which means I get 1, 3 over 2. And this is the midpoint of AC. So we can say here that the midpoint of BD is equal to the midpoint of AC. So BD and AC have the same midpoints. Therefore, BC, and this should say BD, I apologize for that. So we can say, therefore, BD and AC bisect each other. And that's how we've proven that BD and AC bisect each other. There's another way to do this. I want you to brainstorm another method. I don't want you to actually do it, but I just want you to write down a possibility for another method that we can do for this. And we will discuss this next time I see you in class, okay? All right, the next question says to show that the midsegments of a quadrilateral with the following vertices, negative 5, 2, negative 1, 3, negative 2, negative 1, and negative 6, negative 2 form a rectangle. So first of all, let's talk about what a midsegment is. So midsegments will take the midpoints of your shape, whatever shape that you have. You don't have to draw this out. I'm just going to show you right here. You take the midpoints of each one of our sides, and then you connect all of those points. So I want to find the midsegments of each one of these first, okay? So here you're going to want to write small again. So first thing I want to do is find all the midpoints, okay? So the midpoint of PQ would be x1 plus x2 over 2. So negative 5 plus negative 1 over 2. And then I would do 2 plus 3, y1 plus y2 over 2. So the midpoint of this right here would be negative 6, 2, negative 6 over 2, 5 over 2. So I end up getting negative 3, 2.5. Or negative 3, 5 over 2. I'm going to keep this as 5 over 2, but I know that when I graph it out, it's going to have to be at 2.5. So this right here, we will call this A, okay? Let's find the midpoint of QR, and I'm going to call that B. So the midpoint of QR, I'm going to go through, do this again. I'm going to do this pretty quickly because hopefully at this point in time you feel comfortable with midpoint. So negative 1 plus negative 2 over 2. And then I'm going to do 3 plus negative 1 over 2, or I could just say 3 minus 1 over 2. So this ends up becoming negative 3 over 2 and then 2 over 2. So this tells us here, we'll call this B, that B is going to be negative 3 over 2, 1. So this right here is going to be negative 1.5, which is 3 over 2, 1. Okay, next thing I need to do is find the midpoint of RS, or the next thing I need to do is find the midpoint of RS or SR. So let's do RS. It's the same thing. I'm just going to call it RS just so I can go in order. And we'll call this C. So to find the midpoint of RS, add the -2 and the -6 together. Divide that by 2. Then I'm going to add the -1 and the -2 together. Divide that by 2. So I end up getting that C is -8/2, -3/2, which is -4, -3/2. Okay, so I'm going to go to -4 and then -1/2, and this right here is point C. And then lastly, let's go ahead and figure out point D, which is the midpoint of SP. So we'll call this D, and this right here is going to be -6 plus -5/2, and then I'm going to do -2 plus 2/2. So I end up getting that D here is -11/2, 0/2, which means that D is -11/2, 0. And -11/2 is -5.5. So this right here is point D. Now, to show that the mid-segments form a rectangle, the first thing I want to do is connect all of these points together. So here, I've got this shape right here, and I want to show that this is a rectangle. And to show that something is a rectangle, I just have to show that I have right angles. So the next thing I need to do is show that I have right angles, or in other words, I need to show that I have perpendicular line segments. So I need to find the slope of each one of these lines that I have here. So the first line that I will find the slope of is line AB. So I'm going to find the slope of AB first. So I'm going to do y2 minus y1, which is 1 minus 5/2. And I'm going to make this 1/1. And then I'm going to do x2 minus x1, which is -3/2. Minus -3, so this becomes +3. I'm going to make this 3/1. Get a common denominator of 2. So I get 2/2 minus 5/2. And then here I get -3/2, get a common denominator of 2 as well, plus 6/2. So I end up getting -3/2 all over +3/2, which is a -1. So we can say the slope of AB is -1. It's also -1 because anything divided by itself is 1, but it's a negative divided by a positive, which is a -1. You can also just keep the first number, change the division to multiplication, and then flip this 2/3. We can say that these cancel, I have a negative left over, so I have a -1 left over. But you don't have to do all of that workout if you recognize here that you just are dividing a number pretty much by itself. Now I need to find the slope of BC. So to find the slope of BC, I'm going to do the same thing. Take my y2 minus y1. So I'm going to take -3/2. I'm going to subtract 1 all over x2 minus x1. So I'm going to do -4 plus 3/2. Make this 1/1. So get a common denominator. So I get -3/2 minus 2/2 all over. Make this over 1. So I get -8/2 plus 3/2. So I end up getting -5/2 over -5/2, which is the exact same number, so I get the slope of 1. So here we can say that the slope of BC is 1. All right, let's keep going. Let's now find the slope of CD. So to find the slope of CD, I'm going to do y2 minus y1, which is 0, plus 3/2, all over x2 minus x1, so this would become a +4, but I'm just going to make this 8/2 quickly and easily so that I can just do my operations here quickly. If you have a question about it, please make sure to highlight it or write a note so you can ask me why I did that as 8/2. It was just a 4, I just changed it to 8/2. Then I have something divided pretty much by itself, but it's a positive divided by a negative, so I get here that the slope of CD is -1. And then lastly, I can see that the slope of DA is the last thing I want to find now. So I'm going to do 0 minus 5/2, and that's all over -11/2 plus 3. But I'm going to make this 6/2 because 6 over 2 is 3. So I get negative 5 over 2 over negative 5 over 2. Anything divided by itself is 1. So we can say the slope of dA is equal to 1. So here we can see that AB has to be parallel to CD, and we can see that BC has to be parallel to DA, and we can also see that AB and BC are perpendicular to each other, and that CD and DA are perpendicular to each other. So we have shown that we have parallel segments across from each other right here, and that we have right angles. So here we can say, since AB is parallel to CD, BC is parallel to DA, and AB is perpendicular to BC, and that's pretty much all I need, because if this one is a right angle, and if these are parallel, then this one also has to be a right angle. This one has to be a right angle. This has to be a right angle. So really you only have to show that there's one right angle once you show that there are parallel lines here. So we can say, therefore, the mid-segments form a rectangle. And we are done with this question. All right, that's it. Let me know if you have any questions. Otherwise, I'll see you in class. Have a great one. Bye.